All right. Cool. Okay. Thanks, Justin. Appreciate. I'm still learning things about Althea, so that was helpful for me as well. Hopefully for everybody else. So for the next hour and a half-ish.
Hour and 10 minutes.
Hour and 10 minutes?
Yeah.
No, that's fine. We're going to talk a little bit more about intermediaries, and specifically from my perspective, how one would go about building what in Althea terms is called an intermediary, including potentially a cell phone tower. We'll talk about some things about how, if it makes sense for you and your community to get to lease space on a cell phone tower, the things you might consider for that, as well as other things you can use for intermediaries. So first, I think a quick definition of intermediary. In our network here, we have homes. So if we have a really simple network, we have a customer home that is a customer. We have somewhere over there a connection to the broader internet, which is where we purchase a fiber connection or something like that we talked about yesterday. In between those two spots, usually there are some other installations. It's uncommon that we are close enough to be able to connect our home directly to our fiber connection and get them hooked up directly. Usually we need some spots in between to get them connected. So an intermediary is how you take the fiber connection that you're purchasing and get it closer to the community. So you have extra spots. They could be, if we're talking about a wireless network, usually these are high kind of vertical real estate places, grain silos and homes and commercial buildings, et cetera, that you can put wireless equipment on to relay it out toward your customers. It could also, if you're building a fiber network, these are the pedestals in the street that extend the network and add management ability, et cetera. But mostly for what we're talking about in wireless, we're talking about wireless installations where we can install access points and wireless point-to-point connections to extend our service from our fiber out towards our customers. Does that make sense? Any questions on what that means or is? Cool.
And then, of course, with the Althea Network, they can get paid.
Right, exactly. So
the individuals or business owners or property owners that can get paid and work together with the subnet DAO to
right.
set something up.
Right. So to Deborah's point, and for the microphone, in Althea's system, someone who is, if I own a tower or a grain silo or something, and I say, hey, I'd like to help out the community, extend service out to people. I don't really care to be an internet service provider, but I have this resource that could be helpful to people. I'd like to be compensated for making that resource available. I can build an intermediary, allow other people to use it, put Althea's hardware and software in at the location, and then be compensated for usage at the intermediary for traffic that passes through that site. Cool. So, and in addition, I think if I am interested in becoming a DAO, subnet DAO, I'm also interested in building intermediaries and in order to expand my network and connect people to the subnet DAO, right? That's fair to say, right?
Yeah, so if you're a subnet DAO, it's more of a collaborative nature. I mean, the subnet DAO might act to help get subscribers on and work together with that intermediary node. You wouldn't necessarily directly build it necessarily. Depends on the application and how that intersection wants to work. It's more of a collaborative.
Sure. Okay.
And then adding more subscribers benefits both the intermediary tower and the DAO.
Sure. Okay. Okay. So the point is more that as a subnet DAO, I might work with collaboratively with someone who can be an intermediary, and we might work together to build this and extend coverage out to potential customers. But there's interest to both parties, right? Yeah. Great. Okay. So so a few things I wanted to run through on the situation that you are looking to build one of these wireless sites as an intermediary, and kind of physically how to go about building it and things to be concerned about, and how to make sure that the site isn't going to burn down and that kind of thing. So, in a lot of situations when these wireless and a wireless network is being built, What we're looking for is tall buildings. It's quite expensive to build a tower, and it's expensive to build a tall structure. So a lot of times when we're getting started, we're looking for existing structures that we can go put wireless equipment on to act as an intermediary that's already there, it's already being used for something else, and we can now use it to distribute internet out into the community. So it doesn't have to be a cell phone tower. Like I've said, in rural communities, grain silos and water tanks make great intermediary sites. They're already tall. They can hang wireless gear on them. A lot of times they already have power close by. So physically, a lot of times the way that this works is that I, as a person who want to build an intermediary, either I own the equipment or I'm looking to assist with that, I'll go and start looking at the location, and the top things that I'm looking for are if I can hang wireless devices on the structure, like access points and point-to-point radios, and if I have easy access to standard 110 AC power. If I have those two things, I can most likely turn this site into an intermediary. And then once it's turned into an intermediary, I can then begin to serve customers. Any home or any or other building that has line of sight, that can physically see this intermediary, I can now get connected to the network. Any questions? Okay, cool. So yeah.
Isn't a water tank going to experience like absorption problems?
Yeah, potentially. So the question is, would a water tank experience absorption problems? So you would want to make sure that you're not trying to shoot through the water tank, the wireless connection. So you'd have the access points kind of out around the tank and shooting away from it. There could still potentially be a problem with reflections reflecting off the tank and back into the access point on the back. In that situation, you might want to put the access points actually up above the tower or a little bit farther out or closer in. But usually there's ways to make that problem go away if you need to. Good question, though. Let me pull up this other. Okay, so looking at this, this is information I have on my website. You're welcome to look at it and use it. This shows kind of the components of what might be an intermediary. The addition here that I haven't added would be an Althea router. But what we have here is kind of abstract. We have at the top a mount that holds our access points and our wireless equipment. Cables running down to some kind of a switch. In Althea, that would then terminate into an Althea router. And then we have typically a cabinet near the bottom of the structure that holds all of our equipment and is where power is connected. So to go about building this, we find a way to mount our antennas to the structure. We can use a variety of different mounting devices. I think I have a list of them somewhere. Something like this can be used. This is designed to be, yeah.
How stable does the wireless, like the antenna, have to be? If there's a 1-inch wiggle, or is it
Good question.
3 feet?
Yeah. The question was, how stable does the antenna have to be, as in, like, how much can it move in the wind before it starts to cause a problem? Yeah. And that's a good question. It depends a little bit on the frequency that you're trying to use. At 5 gigahertz, if it's moving, if it's wobbling a little bit in the air, it probably won't be noticeable. If it's swaying like this back and forth, it might be. At 60 gigahertz, even a little wobble it probably won't drop the link totally, but it could cause quality problems. So I have to mount that more securely. But at 5 gigahertz, you've got quite a bit of room, wiggle room. Good question. So a mount like this is designed to be put on a flat roof. A common situation is maybe there's an apartment complex with a flat roof. We want to come into the apartment complex, we put something like this on the roof. It's held down with cinder blocks. That's great because the apartment complex doesn't want us to put holes in their roof to mount our equipment. We don't want to do that either because it'll cause leaks and nobody wins. So we put something like this up on the roof. There's a mast in the middle that goes up, can go up to about 10 feet. That gives us a great place to mount our antennas. And should be plenty secure for, there are, if we looked at the technical specs here, it'll tell us how much wind loading there is on this, but this will hold in most non-super extreme weather situations. This will hold quite a lot of equipment.
Do you know what price it is?
Oh, these usually go for like $400, $4 or $450 or something. Then you have to buy the cinder blocks, so that's another $50 or something.
We had a guy make one of these in Colombia for what, like
$60.
$60.
Yeah. I mean, this is
You can
yeah.
weld if you know how to weld.
Yeah. If you know how to weld, you can make this for $50.
We got a pretty smaller one of these, for like 100 150.
Oh yeah.
Something like that, yeah.
Yeah. Deborah points out this is a pretty heavy duty one.
Yeah.
There are ones that are. This will hold, I think, 12 cinder blocks. There are smaller ones for like on top of a customer roof that'll only hold 6 cinder blocks, and they're like $50 or $75.
Yeah.
But they won't hold nearly as much equipment.
So, do you get into any type like agreement? Sorry, I keep bringing agreements, but what communication happens with the, I guess, the building owner,
Yeah.
building manager? Do you
Good
sign
question.
any type?
The question is, what kind of agreement do you get with the building owner? So let me describe my background a little bit, and then I'll try to relate that to Althea. So in my background, from a more traditional WISP wireless ISP background, the situation is I, as the WISP, would approach the building owner and would say something like, I would like to lease some space on your roof so that I can provide internet service out to the area. If this is an apartment complex, I can also provide service to your tenants. And I would begin to negotiate a contract to lease some amount of space on their roof and also compensate them for power usage. Power usage is usually in the US market, it's going to be anywhere from $5 to like maybe $20 a month. And then I might also offer somewhere between $200 and $600 to rent space on their roof. In the Althea system, supposedly I could probably also do that as a subnet DAO, but ideally I would probably be trying to get them interested in acting as an intermediary on their own, such that we would put the Althea router in there that would belong to them, and then any traffic that goes through there, they're compensated based on that being an intermediary. And so, we're collaborating together, but I'm maybe just.
So the role of the subnet DAO in that case would be, to help maybe administer the equipment, maybe to keep it up and running, depending on that situation that you work out between you and the building owner. And the role of the building owner would be to, maybe do the initial investment to keep the power on, to pay for that, and then they would get the reoccurring income from that.
Right.
Yeah.
Right. So just to recap for the mic, in the Althea system, the building owner would kind of hopefully be in charge of keeping the equipment running and keeping the power on, et cetera. They get compensated for forwarding traffic through their router. The job of the subnet DAO would be to maybe do some maintenance on the tower and make sure they might have that expertise to keep the tower maintained and running. But there's a collaboration there that would work. Yeah, is your question? Yeah.
This is like a water tower. Is it hard to get power to the other tower?
Yeah, it can be. So the question is, in the case of a water tower, can it be hard to get power there? And the answer is yes, it can. Depends on the jurisdiction. Some water towers and water tanks do already have power. For maybe they have some monitoring there or something that already happens and they already have it. Or it's in kind of a residential area and it's easy to get. In some cases, there is no power at the water tower, and the options are build a solar installation, which is feasible but can be kind of expensive, or trench power there, which is also feasible but can be expensive. So, good question.
The tree would do the same, I guess.
Yeah, so if you wanted to use a tree to hold one of these equipment, yeah, a tree, I've seen people do that. It seems pretty risky to me, mainly because trees grow and turn and fall over and whatever. And they sway, yeah.
The higher up
Yeah.
you get, there's quite a
Yeah.
bit of sway on those. So you want
Yeah.
to put a sector antenna if you're going to do tree things.
Yeah. What's that?
Guy the tree.
Yeah. So if you really are interested in, and it works good for your community to put it up in the trees, you do probably want to somehow secure the tree, and you want to take some extra steps to make sure that that won't be a maintenance nightmare. But maybe it can work.
For like building over power poles, are those companies usually open negotiations about that? Or they say, we don't worry about that stuff.
Cell phone and power poles.
Yeah.
So I think we're going to talk in just a minute really specifically about cell phone and power companies, but just as a preview, they usually are, but it's expensive. So, yeah. But we'll talk about that specifically in just a few minutes. Any other questions? Cool. Okay, I'll just show a couple of other kind of mounting structures. I think it's helpful. This is helpful for me to be able to see what's out there, and then as you look to go start building these on your own, you at least have an idea what maybe are some of the options that you can use. Okay, a couple of other options. This is just called a tripod mount. This is great for mounting over the peak of rooftops. Mount this over the peak and drill it into the roof. The downside of something like this is that it does require penetrating the roof. So it needs to be sealed really well so that you're not causing any leaks. But they are very sturdy once they're in place, and means that you don't have to haul 300 pounds of cinder blocks up on the roof, which is great. But you definitely don't want to put this on a flat roof. Point of caution, you should never, ever, even if the customer says it's okay, never penetrate a flat roof. Never drill anything into the flat roof. A flat roof, water will pool on the flat roof, and they will leak at some point. If you put a hole in it, it will leak. A sloped roof, they've got shingles, the water slides off. You can seal it, and water won't penetrate because the water will slide off. The water's not pooling up. But on a flat roof, you should never, ever drill through a flat roof. Even if the customer says it's okay. But yeah, for a sloped roof, this is a good solution. They're cheap and easy to put in, and can hold probably a 7 or 10 foot mast, plenty of room for equipment, and easy to install. Another option for a sloped roof. This a non-penetrating peak roof frames is similar. It's meant to go over the peak of a roof like this. Holds cinder blocks on either side. So this is one that will go over a peaked roof but not penetrate the roof. So if the customer insists that you don't drill into the roof, even if you're sealing it, you can use something like this. It holds, I think, 8 cinder blocks. Again, puts a mount up 7 to 10 feet in the air, plenty of room to hold equipment. Mechanically, after we have a mount up in place, a place to hang our equipment, we hang our access points. Yesterday we talked about how you might put 4 or 6 access points around that to give you full 360-degree coverage around the site. A typical situation might have 4 access points around the top of the antenna, and then a point-to-point wireless radio, 1 or 2 of them providing service to the site and potentially out to another site. So you might have 4 to 6 devices on that mount. The next thing you'll do is run a bundle of cables. Each device needs its own Ethernet cable. So we're going to run a bundle of cables from there down to somewhere, ideally where we're going to put a box in where there'll be some equipment, and it'll be equipment that you'll want to be able to get to for maintenance. Whoever's going to be maintaining this thing, you'll want to be able to get to it quickly in an emergency if something's broken so that you can fix it without having to call the maintenance person or find keys or whatever. So in an ideal situation, we might put our box, if it was on a house, outside where it's accessible externally. We'll run all those cables down to the box, and in the box is where the Althea equipment would go. That's also where the power's hooked up. So each of the devices are power over Ethernet through their Ethernet cables, and our Althea router goes in the box. Really for a minimum setup for an intermediary, that's really all there is. A box with a router in it and power, equipment up high, wireless equipment, and that's it. If we want to add in things like battery backup. That's something that can be added. But to just get off the ground and running, that's all we need. Questions so far?
So this is the Tesco vendor. I mean, where would you recommend that people buy this sort of equipment from?
Oh yeah, good question. So, question is where might people buy this kind of equipment from? Tesco is a vendor. What I usually recommend, there's a handful of different vendors in the U.S., and I'm sure there are even more outside the U.S. I have a short list of them somewhere.
You can plug your website.
Okay. Where is it? Here we go. Here's a few kind of U.S. vendors. I don't know if you can see that very well. You can always look it up on my website. I think it's listed in there, and I'm sure that there are others that I'm missing, and I'm sure that there are some outside the U.S. What I typically recommend is call a few of these and see which one of them has the best prices on the specific equipment you are looking for, and also which one of them has distribution centers closest to your area so that you can get fast shipping. I don't necessarily have a preference among these other than just those two things, prices and distribution points. And when you're very first getting started, most of this equipment is available on Amazon for a little bit more expensive than what you get from one of these places anyway. So sometimes it's easier just to do your first batch of ordering from Amazon until you figure out exactly what it is you're using a lot of, and then start looking for a vendor.
So in the scenario of, let's say, a flat land, no structures you can take advantage of, and you're limited to building some type of tall structure, right?
Mm-hmm.
So what would be your recommendation in terms of, because you obviously can build the tower or anything crazy. I guess you can, but if you're limited now by budgets and stuff like that, what?
Yeah, good question. Okay, so the question is, in the situation of a very flat area, there are no tall structures, there are no towers. What are your options? What can you do specifically on a budget to be able to start distributing, right? Yeah. So the first thing I would point out is that there are actually pretty good and not terribly expensive, trying to find it here, options for building a tower. And I think I'll actually use this to move into both building your own tower and also leasing space on a commercial tower that we asked about as well. So let me pull this up. Okay, this is an okay example. Yeah.
Fundamentally, these are same as ham radio towers, right?
Yeah.
Okay. I mean, they look like it. It's
Yeah.
terrifying that there wasn't something different.
Yeah, that's a good point. So the point made up here is there are actually fairly cheap tower structures, and a lot of them are advertised towards ham radio enthusiasts. And so something like this, Roan is a company that makes quick, easy to assemble, relatively inexpensive towers. And a lot of them are targeted toward ham radio people who are largely individuals building something in their backyard. So they're relatively cheap. They can't hold a whole lot of equipment. They're not really, really sturdy, but they're fairly cheap, easy to install. The way that this works is you usually buy them in 10-foot sections. And this Roan 25, you may start to recognize them if you haven't before. They're kind of a triangle. So there's three poles going up, and then they have these cross sections supporting them, and you can build them in 10-foot sections. There's lots of instructions from them as well as from other places on how to actually assemble them. And usually what you're doing is just pouring some cement in a hole, putting the base of the tower, securing it to the cement, and then building up 10 feet at a time. It's not free, but it can be done quite cheaply. In most U.S. jurisdictions, the hardest part of this is permitting. So if you are in a fairly lax regulatory environment, you can pretty easily throw up a tower on somebody's land like this, and kind of do whatever you want. If you're in a more regulatory heavy environment, it can be really hard just to get the permitting. Question.
Okay, so you can find a great way to rent the tower cheaply, but is there any way you could recommend for someone considering upgrading their setup to assess whether the upgrade is going to make a difference? Is there like some sort of makeshift solution someone could use to maybe extend their existing tower or pole or something to, temporarily check that it actually improves reception?
Okay, good question. So make sure I understand the question. The question is, you're saying, okay, maybe I need a tower. I don't want to invest in it until I can confirm that putting up a tower actually fixes it. Yeah, that's a good question. So there are some things actually. I wonder if I could find one. There are temporary portable towers that are used pretty specifically for that kind of thing. Again, a lot of the time marketed toward ham radio enthusiasts that you can temporarily put together. They won't stay there permanently, but it would be enough for you to check it out and see how much signal is improved. I don't.
Military surplus has some cool.
Yeah, military surplus has these kind of things. And the one I'm thinking of is a large, it comes in a big duffel bag, and it's a large tripod that you kind of quickly assemble, and then there's like 6 or 7 foot sections of poles that you kind of push up through the middle. And so you put your antenna on the top one, and then you just start pushing it up, and you can kind of twist it to adjust it. So it's just a really quick throw it together way to do that. The other thing you might consider is just using a drone. Another thing you can do is fly a drone up to the height you might be looking at, get some good video, and see if that gives you line of sight to where it is that you're trying to go.
Oh, actually, I remember there was a project which would use drones in, the areas riddled with disaster where you might need temporary internet access.
Yeah.
They just tether a drone and use antennas attached to it.
Yeah, you can even try to attach antennas to drones.
Just for reference, what's the length that a pole turns into a tower? Say I put a satellite dish up, that's not a tower, just a dish network dish, but
Yeah.
do you have a rule of thumb that more than 5 feet off the roof, 30 feet in the air?
Okay, so the question is, at what point does just a pole, now all of a sudden do we call it a tower?
Yeah,
right?
for permitting or anything else.
Sure. Okay, so there's a couple different ways to look at it. From permitting, it really depends on the municipality. They are frustratingly opaque often. But usually it's if the mayor drives by and doesn't like it, then it's a tower and you shouldn't put it up, But some more practical concerns. If it's tall enough that you can't get to the equipment to service it, then it's going to be really difficult to do anything. And particularly where with these equipments, you need to be able to get here behind it and aim it. And you need to be able to aim it not only left and right, but up and down. If I can't get to the top of my structure to be able to do that, that's going to be really hard. So if I put up, a 50-foot pole, and then what, right? Because I can't get up there and do anything to it. So at that point, it starts to make sense to maybe put up one of these towers that I can then either lean a ladder against or climb. I think that's more practical.
I just didn't know if there was a rule of thumb, over 10 feet over a rooftop is considered
Yeah.
something else.
I usually, if it's going to be more, at 10 feet, I can set up an A-frame ladder and still get to the top, barely.
What I'm thinking of is I put one on my roof, it's like 12 feet, but I have a mount on the side of my wall like this, so I can slide it up and down.
Oh, yeah.
Do whatever, and then put it back up and turn it. But I
Yeah.
don't know, if my neighbors are reporting me or what.
Yeah, no, that's a good point. So there are telescoping towers that you can bring down with a telescoping slider thing, adjust and then crank back up. And yeah, those can be great. It still can be kind of hard because visually it's nice to be able to actually look at this thing that you're aiming and rather than have to crank it up and down. But yeah, those can be good options, and just depends on your municipality.
Do you have any guidance on weight? I guess if you were to mount, if you were to build a tower, is there anything different as far as how much weight you can put on the tower and stuff like that?
Yeah, so the question is, if you're building your own tower, how much stuff can you put on it and how do you determine that? And so there's several things to do. One is that the company you're purchasing the tower from, so if it was Roan, for example, they will publish pretty accurate and useful statistics of what you can put on the tower. And so, you know, a Roan 25, for example, that's this model. It's a small and fairly not really heavy-duty tower. It won't be able to hold as much equipment. They have things like a Roan 35 and a Roan 45 that are designed to be more sturdy, and so you can look at the statistics, and obviously those ones are more expensive, but they can hold more stuff. And typically when you're looking at it, it's the weight is a concern, but the probably even bigger concern is wind loading. So if you're putting, you know, the more surface area of antennas you're putting on there, the more wind it's going to catch, and that's when it'll really start to test the structural integrity of the tower. That's when the wind is hitting it. So there are things that you can do to increase the structural integrity of the tower, things like adding guy wires. Guy wires, if you're unfamiliar, let's see if any of these have good examples. Yeah, oh yeah, that is a good one. So these wires you see coming off, those are guy wires. They're called guy wires. They are attached to the tower and then also anchored some distance away from the tower. Usually there's 3 coming off the tower, and then each of them are tightened. And if you have the physical space to be able to put those, because often they need to go pretty far away from the tower. But if you're putting it in the middle of a field or something, you can add those guy wires, and that'll add a lot of structural integrity to the tower and make it able to hold more equipment with wind loading. Again, the specs for that are typically published by the tower company, or if you really want to be correct about it, an engineering firm should review the design and stamp and confirm what the tower is capable of holding. But you can get quite a ways just looking at the literature provided by the Roan or whoever's doing it to you.
How would you find these engineering firms?
Oh, good question. How would you find an engineering firm? I've found they're not too hard to find in most, at least in the U.S. metro areas, just searching engineering firm and calling a few around. I've never had too much trouble finding them, but they are kind of expensive.
It's just a generic engineering firm.
Yeah, they're the type of people who like stamp bridge drawings or new buildings or like water stuff, or like when you're building a new community and you need to make sure
They're not specific to.
Yeah, it's usually not totally specific to towers. They just have a bunch of smart engineers who can say it looks good or not.
If you have a contractor that you're going to have help you put in the tower, ask them what firm they recommend.
Yeah, that's a good point. A lot of this stuff, especially if you're doing this for the first time, it would be good to have a contractor do it, or at least work with you to do it. And they will usually have contacts into either engineering firms or kind of hopefully have done this before and will be able to help out.
They got to get permits too. So
Yeah. So yeah, definitely possible and commonly done to build your own tower. Again, one of the more difficult pieces comes in that you still need power. So if you are building in a really rural area, again, you might be back to solar power or trenching power in from the nearest available power.
How much does it cost to build something like this?
Let's see, I think the sections can be as low as a few $100s each. So you're probably looking at minimum several $1,000s to get a tower up, or maybe more. For something really short, like if you just need like something 20 feet off the ground or something, you probably do it for a few $100s. But to get more than a few dozen feet up, it'll be more than that. Good question. Any other questions about building your own tower before I move to commercial towers? Yeah.
So if you had a solar panel there, would you have the panels up on the tower? Or that you work on the wind too much?
You probably don't need to put them on the tower because just as much sun hits the ground as the tower. So you really you put them in an area where they're angled toward the sun, and then which can usually be on the ground. I guess if you're in a really dense forest or something, maybe you'd want them a little bit higher up, but usually you just put them on the ground. And just one second. And then actually one of the bigger concerns is you need a pretty big bank of batteries. You need to make sure that you can power through days without sun. So depending on your environment, you might need to be able to power it for several days during winter months without sun.
Is there a rule of thumb for batteries?
What's that?
Is there a rule of thumb for batteries that you want?
The way to calculate it is to look at the longest your area goes without sun on average, or like how many cloudy days in a row, basically, and then how much power your tower is using, and basically give yourself enough batteries that you could power through that length of time. So it varies a lot. I mean, it can vary from almost nothing in really sunny areas to, you know, huge buildings full of batteries in really cloudy areas. So, yeah.
Is there any effective way to deal with wobbling with home towers?
To deal with wobbling?
Yes.
With the tower just swaying back and forth? The best thing is guy wires.
Okay.
So yeah, if you've got a really tall tower and the top of it is going to move, you can try to bury the base deeper and harder in the cement to make the base stronger, but really the best thing to do to keep it in place is guy wires. We'll look at a few more. The other thing is to build a, if you really can't do guy wires, that's just a tiny picture, but you can tell that it's angled. It's more of an A in this particular type of tower, and that will wobble less than the just straight up tower as well. Does that make sense? And you can purchase Roan, I think, and other companies make this kind of tower. So if that's better for if you can't use a guy wire, that might be better. Good question.
Half an hour.
Okay, half an hour left. So let's move on to concerns about commercial towers and how to go about interacting with and potentially leasing space on a commercial tower.
Before you jump off, a basic question.
Mm-hmm.
Climbing these things, I mean, there's obviously safety equipment, but I
Yeah.
mean, how dangerous, I mean, how you've done, I imagine you've climbed up these things. What is that?
Yeah, so the question is, how do you climb these things and concern yourself with safety, make sure you don't fall off, right? Or fall over or whatever. So, yeah, and that's a good question. And actually, there are 2 or 3 companies in the U.S. that will certify a person as able to be tower trained or able to be a tower climber. If you are using a commercial tower owned by somebody else, they will require anyone that climbs the tower to have that certification. So that'll be there. It's not very hard to get. Usually, it's a 2 or 3 day course. Probably costs I don't know, $1,500. Yeah. To go get certified. If you have a crew you're trying to do, you can send one person to get certified and have them come back and certify the rest of your crew. The primary purpose of the certification is to learn how to rescue someone from a tower. So staying safe on a tower yourself is pretty straightforward. You put on a harness and then you have what we call Y lanyards. You've got basically 2 hooks and you never leave yourself unconnected. So as you climb, you hook with one hand, then you climb and you hook with the other hand, so that at any point if you fell, those Y lanyards would catch you. That in itself is pretty simple and straightforward. You can do it with an hour of practice. But the harder part is if you're climbing a tower and you bash your head on something or some ice breaks off up higher and hits you and you are unconscious, someone needs to rescue you. And the idea is that you should always have 2 people working on the tower at any time, and you should both know how to rescue the other person safely. And just briefly, the way that works is that the rescuer climbs the tower to above the person who's unconscious, comes down to them, hooks themselves to that person, cuts that person off the tower, and then descends to the ground. So to get certified, you have to practice that. You have to both be rescued and rescue once a year.
So how do you, what sorts of limits can you have on a tower in terms of like how much equipment you can put on, how heavy can you be max when mounting it?
Yeah, good question. So the question is how much equipment can you put on there and what are the limitations? So the overall process of figuring that out is called a structural assessment of the tower. When you are leasing a tower from a tower company, they will sometimes require you to have a structural assessment done on the tower. Usually what they do is they'll do a structural assessment initially, and as they get closer to having that tower maxed out, they will require new entrants to the tower to have a new structural analysis done to make sure that their equipment won't overload the tower. Again, that's something that should really be done by a professional engineering firm. It's math above my pay grade for sure. But you can also, if you're building your own tower, rely on the published stats from the tower, from the manufacturer of the tower, and they'll give you some information about wind loading and weight. Does that answer your question?
Yes, thank you.
Okay. Okay. So commercial towers. Let me pull up. Well, we'll let that load for a minute. I was just going to pull up. In the U.S., there's a number of tower companies. There's two that most people end up dealing with that are pretty national: American Tower Company and Crown Castle. I was just going to pull up their website just to, show what they look like, but they act mostly as tower management companies. They do own some of their own towers, but mostly they are managing other people's towers. So I'm a property owner and I say I'm going to build a tower, but I don't really want to deal directly with the people leasing it. So I hand it over to American Tower. American Tower now resells the space on the tower, and anyone looking to lease space goes through American Tower and doesn't have to deal with me. So they're in a lot of cases just middlemen to the whole situation. Okay, so here's an example for American Tower, just their homepage. So let's start from the beginning. So you're in an area, and let's say you know of a tower. You're driving around, you see a tower that looks like it would be great for your community, and you want to go figure out how to get some equipment on it. The first thing to do is just drive as close as you can or walk as close as you can to the tower. Almost always there will be a big sign that has an FCC ID on the tower, and it will also say the name of the company that manages the tower, and potentially the name of the company, the name of like Verizon or T-Mobile or whatever who has equipment on the tower. But the sign that says the FCC ID is pretty standard. I wonder if I can find a picture of it. Oh, this one. This is a better example, smaller, but this is one for Crown Castle. I know it's hard to see. There's a little bigger one for Crown Castle. So a sign that looks a lot like that will be at the base of basically any commercial tower that you run across. And I believe that it's required if the site is hosting cellular equipment, basically licensed using licensed frequencies. So this makes it really easy to figure out who to get in touch with if you would like to lease space on that tower. Phone number's right there. You can call them, and you know what company it is. You can also, I believe, both Crown Castle and American Tower do publish maps of all of their tower properties. You just have to sign up for, I think, a free account on their website, and then they'll give you a map of all of their towers. It's possible that the tower you're looking at will not be Crown Castle or CCI, and might be somebody else, either a local company or another more regional tower company. But they should still have this sign and a phone number for you to call. So it's usually easy to get started.
Sometimes, like in the more rural areas, they're run by the Department of Forestry or the government
Sure.
or municipality as well.
Yeah, Deborah's point, sometimes in a really rural area, the tower might be run by the forestry department or some municipality or something like that. And might end up being more difficult to get in contact with, but should still have something like this to be able to find.
Assuming that most cell company or cell towers are in highest points of the area, right, for maximum coverage.
Mm-hmm.
If you wanted to put up say you got permission to put up your own tower somewhere in that vicinity, would you have problems with interference or anything on the cell tower?
Good question. So the question is, if you put up your own tower, or presumably if you put equipment on a tower already there, will it interfere with the existing equipment? The answer is typically no, because cell phone providers are using very different frequencies than we are. If there is another wireless, like a WISP on there, then you might run into concerns about that. And you'd have to work with them or figure out a way to not do that. But if it's only cell phone companies, you probably won't have any interference. So the next step here, you're going to call this company and ask about leasing the tower, and they're going to start asking some questions. This can be a difficult process because usually the tower company has wrong or outdated information or just no information about the tower. So often you have more information standing right there looking at it than they do. But the things that they are going to ask you are how high do you want to go on the tower, and where are you going to put your ground space equipment. So when you're looking at the tower, each of these you can kind of see on this tower. There's bands of equipment. There's I wish I had a laser pointer or something, but there's a section with equipment around it, and then a little bit lower another section. Each of those, they're usually 10-foot sections, and they're called rad centers, R-A-D. I can't remember what it stands for. But it basically just means the height. That's the height that you're going to lease. So basically, you're going to say, I want to lease the 60-foot rad center, and that means you can put your equipment between 55 and 65 feet. So you usually on a large tower, they're rented in 10-foot sections. If you're in an urban area and the towers are really dense and the equipment's really crammed together, it might not be 10-foot sections. It might be more like 3-foot sections. But a bigger one's usually 10 feet.
Does it cost more higher up you are?
Yeah, question, does it cost more higher up you are? And typically, yes. So it's quite common for a large cell phone provider to have the top spot. And often, especially in somewhat rural areas, they're the only ones on the tower. And you can save money by renting lower rad centers. So you might not even want that second spot. If the tower's 100 feet tall, but 50 foot gives you everything you need, you may as well take the 50-foot spot and save some money. So you'll call the tower company. You'll say, I'd like to rent some space on this tower. I'd like to go at 65-foot rad. It looks like it's empty. I'm here at the tower looking at it. It looks empty. Please send me a tower application. And they're going to go through a sales process and get you set up in their system and a bunch of other stuff. And you're going to need to fill out a tower application. The tower application is going to ask you. Actually, let me back up before I get to the tower application. While you're there checking out the site, you want to make sure that you can relatively cheaply get your own power at the site. So you will have to have your own account with the power company providing power at the site. You most likely will not be able to share power with someone else. That means you'll need your own meter on the tower. Usually when a tower is built, there's something like this built. This is an inside one, so not a perfect example, but you'll see something like this outside, usually built on some like unistrut structures where you just have a whole bunch of power meters. If you're lucky, and usually you most of the time you are, at least one or several of these won't have a meter in it. So the meter will be missing and there'll just be a blank spot there. That means that the power company can come in and install a meter in that meter bank that can be assigned to you. You can pay for the power through that meter. The problem is if that meter doesn't exist, they have to expand this whole installation. That can be quite expensive and they are going to make you pay for that. And in a lot of cases, what happens is the existing structure isn't big enough to hold more of these, so they actually make you pay to tear all the existing ones out and put a whole new one in, including extra for yourself, which is very expensive, on the order of 15 to 20 grand. So you don't want to pay for that. So in my past experience, if there's not a free meter bank, usually that means we're not getting on the tower. But fortunately, usually they build enough ahead that there is some extra.
How likely is it to be able to get a quote of a ballpark of the price before you fill out the application, and really get deep into planning exactly what gear and stuff?
Sure, good question.
Sort of estimate.
The question is, how likely are you to be able to get a price quote before you get too far down the road of filling out the application and getting all set up? I think most of the time you're going to end up having to fill out the application to get a quote, but that shouldn't cost too much to fill out. I think sometimes there's an application fee, but it's not terribly high. You might be able to get them to give you a ballpark estimate, but a lot of times the salesperson won't before you fill out the application.
Also, I don't know if you're going to cover this, but do you have any sites you recommend or resources to sort of search like a list of resources of people who supply information on where towers are and who owns them and stuff?
Yeah, so the question, are there resources available for finding basically where towers are and who owns them, et cetera? So yeah, both of these companies, American Tower and Crown Castle, I think do publish their own maps, so you can look at those. You can also, the FCC has not a great map, but ways to kind of search for towers in an area. So even if it's not one of these two major ones, as long as it's known by the FCC has a database that you can search and find those. In the U.S., I don't know much about outside the U.S. Okay, so typically the first thing I do, again, go to the site, figure out how high I want the equipment, make sure there is open space on the tower, check the power situation, make sure there's an open meter bank that I can use, and then go back and start calling the tower company. This is where it does get kind of hard if it's the first tower you've done. They're going to want they're going to want your certificate of insurance, and a lot of times they want like a $5 million coverage. So that can be kind of expensive if you're just getting started to get that amount of insurance. And they are also going to want things like being able to see that everyone who's going to be working on the tower has safety training. A lot of times they want to see your OSHA logs from doing similar work and proving that you are working safely. So building that relationship with the tower company can be difficult just getting started.
Can you contract that out to have someone else put your equipment?
Yeah. So the question, can you just contract this part out? And the answer is yes, definitely. There are quite a few companies that will just build this for you. In fact, most large carriers in the U.S. don't do this themselves. At least in some areas, they hire out tower contractors, and those contractors are typically more than willing to take your business.
Would look for specifically a tower contractor, or would like a general engineering firm do that kind of thing too?
So sometimes large electrical contracting firms have a tower division that does tower work, or sometimes there's just a more local tower-only contracting group that does this for a variety of different cell providers. Again, though, they're going to be quite expensive. So they'll usually have a crew of two to four technicians, and the technicians, I think, rightfully are pretty well paid because they're climbing towers, and that's kind of a dangerous situation, and there's overhead on top of that, so it can be quite expensive, but certainly possible. Good question. If you're and a lot of times they won't do this negotiation process for you. You still have to negotiate directly with the tower company and then get the contracting crew to go do it. So usually you're still doing the tower piece yourself.
I mean, as long as we're on that, how skilled are they typically at doing things like aligning your point-to-point? Is that something you need to look into separately?
Question. So the question is, if you're contracting this out, are they going to be skilled enough to align your point-to-point stuff correctly? Or do you need to figure out how to train them or something like that? It depends on the firm. Usually they have at least enough experience. They've been doing this stuff for cell phone providers, and maybe they haven't done a lot of point-to-point stuff, but usually they can with some training. But it is something you would kind of want to assess if you're looking at a contracting group. You probably do want to spend some time with them and make sure they understand the specific equipment that you're using and how to aim it. Or you may potentially be able to have yourself or someone from your organization there with them on the ground, making sure that it's done right and done well. Good question.
Sure, if you start somewhere of estimated tower costs in different locations, get that like Zillow?
I don't know of one. That would be nice. Usually, my experience is that it's anywhere from $800 to $2,500 a month for a tower, and they do often want fairly long-term contracts, 3 to 5 to maybe 10 years. So that's a rough ballpark. There are sometimes some startup fees. The next step here is you fill out a tower application, and they're going to want to know everything you're going to put on the tower, all of the lines that you'll run to the tower, whether or not you want to use their battery backup or generator system if they have one. and how much power you'll be using, although you'll be paying for that directly. And they'll want to know everything about the antennas you put up, their size, their weight, the direction that they'll be aiming, what type of mounts you'll use on the tower. So they really are going to want a pretty thorough application. And then once you've submitted that application, they may come back and say, hey, we need to do a structural analysis to make sure this tower can support what you're doing. And you will, of course, have to pay for that. And that's usually around $2,500 to $4,000 or something. They'll usually take care of having that done, but they'll bill you for it. So if you've made it to this point and you've got the tower application and they're going to allow you to do it, the next thing to do is to find a contractor, an electrical contractor that'll come in and install the electrical for you. That probably does have to be done by a contractor just for permitting. The power company will want to come and inspect it before they actually turn it on, and they will get very mad at you if you didn't use a certified electrician. So unless you are a master electrician in your area, at least in the US, you probably will have to contract out the electrical part. And then, you know, if you get to that point, that's when you can then start installing equipment on the tower. So it is a pretty long and involved and difficult process. But you know, sometimes this is the only way or a really great way to get service out into the community. A couple of other things to note. There are some regulations in the US requiring cell phone companies to allow co-location on their towers. So even if Verizon, for example, owns the tower, they are required to at least put forth some good faith effort to allowing you to add equipment to their tower, even if you will be competing with them. They may drag their feet. It may take 18 months, but they are required to do it. So, you know, don't let them brush you off if you really need that tower.
So, like, how selective are these things? Like, if you wanted to, like, pay the money and put, like, big googly eyes up or something, like, can you do that? Or, like a weird science experiment or something? Like, how much do they want to make sure that you're doing something, like, ISP related?
I don't think they care. As long as it passes the structural, it's not going to blow the tower over. There may be city regulations for aesthetics, which actually I should talk about that. So there may be some municipality regulations for aesthetics that you have to abide by. But other than that, I don't think the tower company will take your money as long as it's not going to hurt the tower. But that is a good point to talk about aesthetics. If you go to a tower and you're looking at it, sometimes you'll see a tower that is made to look like a tree. I think we've all seen those. So also sometimes you'll see one that has kind of a fiberglass covering around the equipment, so it looks like just a, I wonder if I could find it. There's one. So there's a lot of different ways that tower equipment, sometimes even you'll see, you know, a church and it'll have this massive steeple in front. And, oh yeah, cactus. If you see that, it's probably not because the tower company did it out of the goodness of their heart. It's probably because the city requires it. And so you'll probably have to do the same thing. That can be really difficult and expensive too. So if you see a tower that has these stealth features built in, kind of be wary that you're probably going to have to do something similar.
Does it impact signal strength?
Yeah, question. So does the fiberglass covering impact signal strength if you're trying to shoot through it? It does. It can. What I understand is that it can be as low as like a dB or 2 loss, which you have to account for, but can maybe still be manageable for what you're trying to do. But yeah, it can impact the.
So how about getting the fiber to the tower? Is it always there? I mean,
Sure.
You know.
Okay, so the question is, how about getting fiber or whatever service to the tower? Is it already there, or how do you go about doing that? So it really is like any other location. It's somewhat more likely that there has been fiber run to the tower, because if there's another provider there, they may have required fiber to be there, and you may be able to also lease it. But it's just as useful and often cheaper and better for what you're trying to do to just use a point-to-point wireless connection to get your service to the tower, and then also go out, so you're not paying for that fiber lease. If you already have a fiber connection within line of sight of that tower, it's probably cheaper just to feed it that way rather than buying a new fiber connection.
So what's the security story like with the ground equipment? Like, do they typically, once you're paid up, do they just like give you a key to like a padlock, or like are there like security cameras typically, or like barbed wire? Or?
Good question. So the question is, how secure is the ground facility? And it does vary. Usually there's at least a fence. A lot of the time, either they will give you the code to the gate key, or sometimes they'll just have you loop your padlock through the other padlocks so that everybody has their own padlock. And in denser urban areas, they might have more physical security, but they're not tremendously secure. I haven't often seen security cameras, unless they were put in there by the. A lot of times, the cell phone companies will actually build a hut, like almost a shed, where their equipment is secured, and those are fairly secure locations, big metal doors and solid construction. But as far as just getting into the facility itself, it's usually just a fence.
For a couple more questions.
Okay, 5 minutes for a few more questions about commercial towers. Was there anything I missed? I think I have it.
So how much would it cost in total to get it up and running to that point? Like, I know you said you got to do analysis, that would cost you $3,000, and then you got to install it and everything on average.
Yeah. So the question is, how much, ultimately, how much does it end up costing to get yourself on a tower? So I would say the startup, just getting to the point where you can get on the tower will range anywhere from maybe $1,500 to $7,000, depending on what they require. And then again, most likely you'll end up spending $800 to $2,500 a month to lease the tower space. Any other questions?
So normally they're dealing with a business. So is there any way that you, is it a problem just do it as a regular person, or is it always that you have to have some sort of legal entity to be able to engage in these agreements?
So the question is, they're accustomed to dealing with businesses, so can you engage with them as an individual, or do you have to have some kind of legal business entity?
Yes.
And I think the primary answer to that question is that they do usually require a pretty high amount of insurance before you can engage with them. Whether or not they actually require like a business entity, I don't know that they necessarily do. So it may be possible if you are contracting all of the labor to engage with them as an individual, with the letting them know ahead of time that you're using a contractor to do the actual build, and that the contractor will carry the insurance. That may be possible. I haven't personally tried it.
All right, you want to go ahead and break for lunch?
All right.
All right, let's go
Lunchtime.
ahead and break for lunch, and we'll see everybody back online.